why scaling Agile doesn't work and what to do about it. I didn't get straight to the point. The reason scaling Agile doesn't work is because Agile is just one piece of the puzzle. The industry standard process for software development in most companies is still a process that I like to call water scrum ball. Here problem is this: even if you're doing kind of nice iterations here, even if you're doing kind of Agile stuff here, often it's the case in a company of more than 1,000 people, and even if you work in a small company, you probably have this thing where before anyone does any work you spend months. You know, someone has an idea, you have to go and write a budget proposal, it has to go through the budgeting cycle, you have to go and do big long estimates and work out how much it's going to cost and how long it's going to take, and then you have to do the design phase, and then eventually some enormous document lands on someone's desk, and then you can start development. And we are doing development in nice little iterations, and that's great, but you can't actually release anything. Before you do that, your work and the work of the other teams has to be integrated, and then it goes to central testing, and then hopefully you manage to fix some of the bugs you found in testing, and then it gets tossed over the wall to IT operations, and only then does it actually go out to users. And this is the point where we actually derive measurable customer outcomes from the work. And so this overall cycle time or lead time, depending on how you define the words, the time from golf course to measurable customer outcome is usually pretty long, and making this bit in the middle of Agile usually doesn't make a big difference. It might make a difference of a few percent, but I mean, whenever I go and do value stream maps at companies, it's usually like, oh yes, this bit takes 9 months, but let's not talk about that because we can't do anything about that. And I'm like, whoa, that's the bit you need to fix, because it doesn't matter how much you mess around with this stuff. If it's taking you 9 months to go through this, you're not making a big difference on the overall outcomes. So first of all, what tends to happen when you do kind of Agile in this environment is you end up creating a lot of teams, and the way that is usually made to work is you still have to do all this stuff, and then you take all the work and you break it down into lots of tiny little bits, and then you hand the tiny little bits out to all the teams, and they go off and do the tiny little bits, and then at the end they come together and kind of try and make the system as a whole work, and it doesn't. And you have to spend weeks or months actually trying to make it work, and when it does work you find out that it wasn't really what you wanted, and you're like, oh, but now we have to release it because it's taken us a year or 2 years to get here, and you know it's on scope, it's on time, it's on budget. So yeah, so you release it, and then maybe like me, you had the experience where you rolled off the project and you enter do something instead, and then like a year or 2 later you were talking to one of your colleagues, he's still on the project, and they're like, oh yeah, that thing that we built, no one actually ended up using it. It was cancelled, or went to market, wasn't successful. And that for me was the most miserable moment of my career. This thing that I built, that I spent a year on this large team where we thought it was a success, but then the thing actually never ended up making a lot of money for the company, and after a couple of years it got cancelled. So Agile doesn't fix that problem, because fundamentally the problem is the ideas that you had at the beginning wasn't the right idea, but it took you so long to find out that it wasn't the right idea. There you were, you were screwed. And then you look at the decision-making process. So I love running surveys. Surveys are a really rich source of confirmation bias, and so here I got the survey result from Forrester to find out about Agile practices. One of the questions they asked is how the companies make investment decisions for products. So 47% of people replied that the committee decides from potential options, so decision by committee. So 24% of people said they use some kind of financial modeling, they use economics to make their investment decisions. That seems like a good idea. For a joke, they put opinion of the person with the highest salary wins out. 13% of people answered that that's how they made decisions. This is called the Hippo method, the highest paid person's opinion. And that really is the same thing as committee decides from central options, so that are actually the same thing. And then 9% of people said they use a product portfolio approach, which is also the same thing as this. And then some 7% people, which I thought was very admirable, said that they take no systematic approach, which is basically also the same thing. So what we can see here is that 76% of people are not using an economic framework, and 24% of people are using an economic framework, which is kind of depressing. So that's the state of software development and portfolio management investment today. And in most big companies, what you find is the output of this process is a few very big projects, because somehow the annual budgeting cycle leads to a few big projects being the ones that get funded. And so, as an example of a retirement savings account, so I've got a product that I want to sell you. If your retirement savings account, and in my products I Have four big things that I'm building and it's going to take me a really long time to build them, and at the end we don't know if they're going to be successful or not, and it's going to take us a really long time to find out, but if they are successful they might make lots of money. Would you like to invest in my product? No, because you're not stupid, and yet that's exactly what we do with the IT budgeting process for building projects. In most cases, we'd be better off taking our money and pressing it into unit trusts that would provide a better return on investment than our IT budget investments, and the things that we do to mitigate the risk of being wrong don't work. So the main activity? What's the main activity we perform to make sure that we should really do the projects? The main analysis activity, business case. And what's the main kind of analysis activity we use to create the business case? So return on investment is the main thing we want to know about, but what do we spend our analysis time doing to find out if we'll get rich investment? I would love to know that people actually put effort into finding out the potential business value. That's not where I see most people putting their effort in analysis. What I mainly see the effort being is estimation. So estimation of cost, that's where I mostly see people putting in a lot of time and effort, is working with the developers to estimate the amount of work they're going to do. The problem with that is it's pointless. So there's a guy called Douglas Hubbard who wrote a book called How to Measure Anything, and he's been looking at business cases for many years, and he does a kind of analysis called Monte Carlo. In Monte Carlo, you change the inputs to the business case and you see the impact of changing the values on what you care about, which is normally either return on investment or life cycle profits for the products. Those are the two variables you care about, and what he found is that the cost has a very low information value. Varying the cost actually doesn't have a huge impact on return on investment or life cycle profits, which is what you really care about. The single most important unknown he found is whether the project will be cancelled. The next most important variable is the utilization of the system, including how quickly the system rolls out and whether some people will use it at all. And those are the two things that you care about. Is it going to get cancelled? And when it rolls out, are people going to use it? And that's true for internal IT projects and for external product development. Is are people really going to use it? And that's the thing we don't normally spend a lot of time finding out, and that's for me the whole point of the lean startup, is how we can cheaply run experiments to find out if people will actually use it and pay you money for it. And that is way more important than any kind of estimation activity, and yet it's much more rare to find people doing that than it is to find them spending weeks or months doing in a very detailed estimation. And then once you've done the estimation, you take all the little bits, you basically break it down a little bit, estimated little bits, add it all up, and then you give the people all the little bits to do. We're back where we started. So the other problem with this approach is that we create these huge projects, and when we create huge projects, we batch up all these little bits of work together in one big batch, which we then push through the process. And part of the reason we do that is because the transaction cost of taking work through the entire value stream is so high, and so part of the point of continuous delivery is to make it economic to work in small batches so we can get the feedback much more quickly. So that's kind of a quick preview of the continuous delivery thing. But when we batch up work, what we do is we batch up that very high value things with lots of very low value things, and you push them all out together. There's a really good case study called Black Swan Farming using cost of delay. This is a case study that was done on Masks, which was the world's biggest or second biggest shipping line, so a really big company with lots of IT projects, and they had about 3,000 different features that were going through the value stream from analysis through development and delivery. And one of the first things they did was try and estimate the value of these pieces of work, and they did this using a method called cost of delay. So if you go to this link here, you can download the paper. I really highly recommend this paper as a case study of how to implement Lean Agile at scale. What they found that was really interesting is by using cost of delay to measure the value of the feature. So what cost of delay is briefly is how much it costs you per unit time per week in this case to not deliver the feature. So every week that we're not delivering this feature, how much is it costing us in opportunity cost to not deliver it? And that's the way that you can prioritize work in dollar value by considering the opportunity cost. I'm not delivering it and comparing it. And what they found is of these thousands of requirements that were going through the system, there were about 3 that it was costing the company, between $2 and $2.8 million per week to not deliver. And then you've got this long tail of features where the cost of delay is, negligible in comparison with this. And so it becomes very clear, like, what should we work on? You've got this big IT team. They should stop doing everything except these 3 bits of work and deliver these 3 bits of work as fast as they possibly can and stop doing anything else. And when you're not even exposing the value of what you're doing, and you know they were making assumptions to come to these numbers. It can be quite hard to work out the dollar value of these features, but when the variability is quite high, it doesn't even matter. When there's like an order of magnitude difference between the value, doesn't matter if I'm wrong by a factor of 2, who cares, still going to be really obvious which the features are. And Joshua Arnold's done a bunch of other projects where he's analyzed things in this way, and he's found that this shape, this is a power law curve. This kind of power law distribution is very common most places where they've gone and looked at the value of the features. It's been this power law curve, so this is pretty typical of what you'll find is that a few small very valuable things get bashed up with a ton of other stuff that's low value, and then when you have these big batches of work going through the system, it's really hard to prioritize the individual bits. So what do? First of all, the whole project paradigm is based on the assumption that the features and requirements that we've created are in fact the right thing to do almost always. As we'll see, that's not true. They are the wrong thing to do. About 2/3 of the time, the features that we want to build have zero or negative value and are not the right thing to do. I have data to back this statement up, which I will give you the reference to. In the case of new product development, the numbers are much worse. It's more like 90% of the time the product's the wrong idea. So for established products with well-known business models, that what 2/3 of the time the features are zero negative value. With new products where there's a larger amount of uncertainty, over 90% of the time it's the wrong idea. So we shouldn't optimize for the case where we think we're right about what we're building, which is what the project paradigm does. Instead of focusing on cost and spending a lot of work on estimation, we should focus on value and gathering information to justify the value of what we're building. One of the most important things we can be doing is creating feedback loops throughout our delivery process and making sure that the decisions we make, whether that's the product's development decisions, the investment decisions, the requirement decisions, are actually the right thing. How can we get the feedback on those decisions as fast as possible? And then within the development process, we want feedback loops. Did I break the system? Did I introduce the performance degradation? Did I introduce a security hole? This is part of the point of continuous delivery in the deployment pipeline, is to create really effective rapid feedback loops within our delivery process. The point of continuous delivery is to make it economic to work in small batches, and working in small batches is what allows us to get these feedback loops working, so that we can get those feedback loops operating at a high frequency. By working in small batches, we get feedback at high frequency, and that allows us to course correct much more quickly, which is the whole point of Agile. And when we've done these things, then we can enable an experimental approach to product development based on the scientific method. I have a hypothesis about a feature that I want to build. How do I test whether my hypothesis is correct? What data can I gather to validate my hypothesis? And we can apply this experimental approach not just to product development, but also to process improvement, and continually work to improve the quality of our development and delivery processes. So the first idea that I want to attack is this idea of requirements. Whose requirements are they? Are they the user's requirements? Users don't know what they want. Users know what they don't want once you build it for them. They're the requirements of the hippo, the highly paid person. And so I don't like this word requirements. What we have is hypotheses, and typically there's more than one way to achieve the outcome we want to achieve, and a lot of the time we're not even thinking about the outcomes. So who uses stories in their projects? If you've written a story where you kind of left out the so that because it was kind of a bit hard to think about it, yeah, most of us have done that at one time or the other, and it's actually pretty common that is missed out most of the time, like more than 50% of the time. So we all know that that's the most important bit. But in the day-to-day kind of work process, it's kind of easy to forget that, because you know that it's important and we've got to do it, so let's just do it. I think we should focus much more on the outcomes. So one of my favorite tools is this one by GlycoAdzik. They're called impact mapping. It's a very simple idea, but it's very powerful, and his idea is this: we should work backwards from the outcome. So this is the outcome we want to create. This is just an example, right? Reduce transaction costs by 10% for a trading platform. So this is an impact map for a trading platform. Reduce transaction costs by 10%. Who are the stakeholders? Well, there's a German settlement team. I didn't plan, by the way, that I would deliver this in Berlin, just happened that way. There's some traders, there's IT operations. Here at the second level are the ways in which these stakeholders could help or hinder this outcome, and then at the next level are the actual stories. This is the what you could do to achieve that outcome. And when we do analysis, what happens is you pick one and then you throw everything else away, and then that one thing is what goes downstream to development and then tidy operations, and that's a real problem. A lot at the time the developers never even see the rest of this map. They just go improve exception. reports so that you know trading costs go down, and often the number which is really important, like how are we going to measure the success of whether we're done, is thrown away. So actually having the key thing about the impact map is not creating the impact map. The key thing about the impact map, as with most Agile practices, is the shared understanding of the whole team which is created when you build the impact map. So we have this thing in Agile that's everywhere where you focus on the artifacts, not the important thing. The shared understanding of the team that created the artifact is actually the important thing. So here what's crucial is having the developers and the operations people and the business people all work together to create the impact map and then pick one, like which is the thing that we think will be the smallest possible work for the biggest outcome, because as Jeff Patton likes to say, what we want to do is minimize output, maximize outcomes. So we want to maximize the outcome. What's the minimum amount of work we can do to achieve this outcome, and you pick one, and then you design an experiment to test whether it will in fact achieve this outcome. So the other thing I really like that fits with this really nicely is Jeff Golf's template for hypothesis-driven delivery. So instead of the story format, he has this format: we believe that building this feature for these people will achieve this outcome. Well, not as successful when we see this signal from the market. What's the signal we're going to measure to prove that the thing we are building will actually achieve the outcome? So we believe that building this feature for these people will achieve this outcome. Well, not as successful when we see this signal from the market. What are we going to measure to demonstrate the feature will actually deliver? And there's many ways we can measure the outcome using an experiment. Most of this comes from the UX movement, and one of the big trends in Agile is integrating UX, but often what I see, UX is basically making it look pretty. That's not the point of UX. The point of UX is to help us think about delivering things in a way that will satisfy our customers. So the whole way in which our customers interact with our products and our company is all within the realm of UX, including will the features, will the products actually make our customers happy and our users happy? So this is from Janice Fraser, and she divides up user research based on whether it's quantitative or qualitative, and then whether it's evaluative or generative. So generative in design thinking, there's two phases. There's the bit where you generate ideas, which is where you can have come up with lots of different options. So building an impact map is an example of a generative behavior, and then evaluative is when you narrow down the options and pick one. So that's a conversion activity. That's the process of deciding which option is the right one. So you can use user research to create the whole bunch of ideas, and then you can use different techniques to find out which of those ideas is actually going to produce the required outcome. But there's loads of ways to do this that don't involve actually building out the whole feature. And so you should be thinking very carefully about how we can gather data without building out the whole feature and then finding out whether it was a good idea, because usually what happens is, even if you find out it wasn't a good idea, there's the sunk cost fallacy. You don't want to admit you spent all this time building this thing that's useless. So in terms of an alternative to water scrumfall, I like to show this slide from Amazon. This is from 2011. They're about an order of magnitude better right now. They are making changes to production on average every 11.6 seconds, up to 1,079 deployments per hour, up to 10,000 average boxes receiving deployment, up to 30,000 boxes receiving deployment. One of the reasons they did this was to get this. Kahavi helped to build Amazon's experimentation platform. He was in charge of Amazon's experimentation platform. Then he went on to work for Microsoft and was in charge of the Bing, still in charge of being experimentation platform. So he has loads of data from a feature development, and this is the important piece of data. We could be spending 2/3 of our time on the beach skiing at home with our kids. If only we knew the 2/3 of the features that we build that have zero or negative value to our company. And people don't think of the negative value case, the case where you're actually making things worse, and that kills us in 3 ways. Firstly, there's the opportunity cost of not building something that would have delivered value. Second, features add complexity to our system. They have to be maintained forever, so the maintenance cost. And third, that complexity slows down the rate at which we can add new features, so it makes new feature development slower. So if you're not doing experiments to find out if your features are actually valuable, you're killing yourselves in these three ways. Is the biggest source of waste in software delivery is the stuff that we build that delivers zero or negative value. We should running experiments to test the value of the features and products they're building. This is the biggest thing, in my opinion, that we need to change our industry, is be thinking about how we can actually gather data to validate whether the things we are doing are actually delivering value for our customers. And it doesn't need to be A/B testing. It could just be other forms of user research. The cool thing for me about software is that software has different characteristics from architecture in terms of buildings, right? So people often say I wish software could more like buildings, meaning that they wish it could not fall down and be reliable and be secure and things like that. But actually I think that's false. We don't want software to be like buildings because software has these really unique affordances. Software is easy to change even at scale compared to buildings. If I want to really check this building, I have to pull it down and start again from scratch. You don't have to do that with software. Helps of people do that with software, which is unfortunate, but you can actually rebuild the plane while it's in flight with software. You can make architectural changes incrementally. It's entirely possible to do that. People have done that very successfully. Software is much cheaper to change. You can get value from software before you finish building it. Like you couldn't be in this building if there were no ceilings here, but I can develop a piece of software which doesn't serve all of your needs but might serve the needs of a small segment of you. And you might be able to get value from that from really early on. So software has these unique affordances that makes it much easier to experiment and try things out, and we can't do that with buildings and with physical architecture. And what's cool about that is we can use the same techniques for experimental product development that the lean movement has been using for years for process improvement. So to show you what I'm talking about, I'm going to give you a case study. And the case study is from HP Laserjet firmware division. I'm going to focus on how they made the transition. So this was a team that in 2008 had this really big problem, which is that they were on the critical path for software development. Every new range of printers they wanted to launch, they were going to have to build new firmware, and that was going to take longer than actually building the chips that went into those printers. So that was a really serious problem. I actually know for a European airline, and they were introducing, the economy seats with bigger gaps between the seats, right? Like premium economy, more legroom. It was going to take them longer to change the booking system so that you could book the seats. The net was going to take them to put the seats into the airplanes, right? Which is how there's something really badly wrong with your software delivery process. So there's the same thing here. It's going to take them longer to build the firmware than it was going to take them to fabricate these custom chips, which had a 1-year lead time to be able to build. So they tried a whole bunch of different things, and eventually they decided to look at their software delivery process. What they found is they were spending a whole bunch of time doing non-value add things like code integration, very detailed planning, porting code between branches. Every time they released a new line of devices, they took a branch and version control, which meant that when they fixed a bug in one line of devices and they needed support the bug fix, they would have to port it across all these code branches. Same with features. They were spending 25% of their time porting features and bug fixes across branches, 25% of their time on product support. What is this telling? Quality problem. 15% of their time on manual testing. If you subtract this from 100%, what you find is that only 5% of their investment was actually being spent on building features. And by the way, all the product management people, they would say, can we get budget for, adding test automation? Can we spend some time refactoring? And management be like, no, you've got to build the features. And it's very clear to see the fallacy in that idea, because here's the thing, the reason that there's all this pressure to build the features, the reason you're going so slowly is because you're spending all this amount of money on things that are not adding value. The only way you can get that problem is by fixing this, by removing this that will allow you to go faster. So you have this vicious cycle, pressure. You have to fix, you have to do the features. Why is the pressure there? Because we are doing all this other stuff. It's so painful to deliver anything, and if we don't fix this, it's always going to get worse and worse and worse until we're just driven into the ground. They also looked at their cycle times. It's taking a week to get changes into trunk. They were getting 1 or 2 builds a day, and it's 6 weeks to do a full manual regression on their software before they could release it. So they didn't want to do continuous deployment. They didn't want to release new firmware 10 times a day. But what they found is by implementing continuous delivery, by working in small batches, it changed the economics of the software delivery process, because it created feedback loops that enabled them to build quality in rather than try and test quality. And at the end, and over the course of 2 years, and well, first of all, they're architected in a big bang way, which is always very risky, that I don't recommend it. But in this case it works, and I'll explain why later. But their architecture such that they didn't have branches for different ranges of devices anymore. Instead, they had one firmware build that would work on any set of devices. So the firmware boots, looks at the hardware profile, says, oh, I'm a printer, I'm going to turn these features off, I'm going to keep these features on. Or boots looks around, says, oh, I'm a scanner, so I'm going to turn these features off and turn these Features on, so it's basically feature toggles for architectural differences. So a guy has a saying, feature branching is a poor person's modular architecture. So this is a case where they're architected so they wouldn't have to use branches, and that allowed them to work on trunk and do continuous integration and build a very sophisticated test automation suite where they had over 30,000 hours of tests that would actually send signals to the logic boards and then get signals back as part of their test automation. So anyone who complains about test automation for websites, I actually spank people who whine about test automation, because now here's people who did it with logic boards. That's super cool. So they built a very sophisticated set of automated tests anytime anyone hacked in. They used at scale 400 developers on 3 different countries, Brazil, USA, India, or pushing changes in to Git. They each had their own little repo, and they built a CI tool that looked at those repos anytime. So, and pushed at range, it would take that change and run 2 hours worth of automated tests against that change in a simulator. If that works, it gets promoted to the stage 2, and then what happens in stage 2? Is all the changes in the last time period get merged, and then they run automated tests in the simulator against that merged set of changes. If that fails, the developers get an email, here the test that broke, here's a button to be able to reproduce those test failures on your development workstation. That's super important. If developers can't reproduce the acceptance test failures, that's a very serious problem. It's an architectural problem that you need to fix. If they succeed, that's the only way you can get into trunk. So to get into trunk, anything that passes stage 2 gets into trunk, and that's the only way the developers can get into trunk. So this basically fixed the problem where the bill's always red because the developers don't care about it, because guess what, the only way you get into trunk is if the bill is green out of level 2. This runs on a big rack of servers in a simulator. Another 2 hours worth of automated tests, then you get promoted to level 3, which runs actually on physical logic boards with emulators, and then if that works, then it gets promoted to the overnight level 4, and that's the entire 30,000 hours worth of test run in parallel. So you get the results overnight, and so you can find out if the firmware is releasable within 24 hours of making the check-in. So they completely remove the 6-week stabilization phase that just goes away. And the whole point of continuous delivery, by the way, is to get rid of this whole thing. Like, this whole thing should all go away. Even if you're not releasing 10 times a day, you should be able to release yourself. I should always be provably reducible on a daily basis. That's the point of continuous delivery. And so even if you're not doing continuous deployment that produces huge benefits, they massively reduce the amount of time they're spending on code integration and on planning and on porting K between branches. Product support activities goes down from 25% of costs to 10%. Of course, what does that tell you? Higher quality. So this is how they measured the quality improvement. Manual testing goes down for 15% to 5%. Costs invested in innovation go from 5% to 40%, so 8x improvement in productivity measured in terms of the amount of investment going towards innovation. What do the arithmetic notice about these numbers? It is less than 100% because there is a new activity: creating, maintaining, evolving the suites of automated tests. If you enter your manager right now and said, please can we invest 23% of our budget in test automation, what would your manager say? That's a rhetorical question, and yet here we have the business case for doing that. The business case is quite clear. Despite the fact you've got 23% of your budget spent on test automation, that has enabled an 8x improvement in cost spent on innovation because it's massively reduced the amount of non-value-added work we're doing. And this is how lean works. Lean works by investing in removing waste so that you can increase throughput. And the reason I like to talk about this case study is because they wrote it into a book, and you can get the book, and here are the numbers to take to your CFO to explain why they should invest in its newest delivery. And how they did it was really interesting. They did not create a 3-year plan in detail of how they were going to do this. What they did is they had a goal. Their goal was twofold. 1, get firmware off the critical path. Goal 2 is 10x productivity increase. So that's all they wanted to do. They had no idea how they would do it. But they set these 2 very measurable, easy to understand goals. Like, everyone can understand those goals. It's really obvious, and it's really obvious when you achieve them, and when you haven't achieved them, that's super important. Anytime you're implementing Agile or DevOps or any methodology, step 0 is to understand your goals in measurable terms. What goal are we trying to achieve? How will we know when we've achieved it? There's acceptance criteria for organizational transformation. What's our goal if you implement Agile because Agile is cool or because it will make things better? You will fail. You've got to Understand what the goals you're trying to achieve are for your organization in measurable terms, and then we want to take an experimental approach to achieving those goals. So what's some intermediate goal which will get us some of the way there? Let's try a bunch of things out to find out if we can achieve that intermediate goal. If we don't succeed, we've learned something, but we haven't spent too much time learning it, which is important, and if we succeed, that's great. Let's try the next step. So this is crucial. We're taking an incremental approach to process improvement and to changing organizational behavior in the same way that we take an incremental approach to product development. The incremental iterative approach doesn't just apply to how we do product development, it also applies to how we do process improvement and how we improve our companies and our processes, and it's something we should be doing habitually as part of our daily work. And what was cool is that this was a case study for something that only got written about subsequently, which is true. I mean, they were doing it in its livery. They didn't call it continuous delivery, they called it getting better at engineering, right? Didn't need a name. He was like, oh yeah, we're just trying to get better at what we're doing. And in the same way, they also simultaneously invented this thing, the improvement cutter. So a cutter comes from Japanese martial arts. It's a habit. It's a best practice that you practice over and over again until it becomes habitual, and it's the same idea. Whereas music, you practice scales over and over again. That's the first thing you do until you get really good at it, and then you move to higher order practices that combine the things you learn. Same thing with sports, you learn the basic moves for tennis, and then you're able to combine those any human creative activities. The same thing, you learn the basic moves first and then you until they become habitual, and then you combine them into higher order creative processes. So his point is with this book, Improvement Cutter, based on the study of Toyota's management method, is that improvement work, getting better, or what we do, should be a habitual process. And here's the basic practice that you have to practice over and over again in order to get better. First, understand the directional challenge. So HP laserjet, 10x productivity increase, get firmware off the critical path. Number 2, grasp the current condition. Step 3, establish the next target condition. So I'm going to show you what a target condition looks like, but it's basically an intermediate measurable set of goals for the program as a whole, and then you don't plan how you're going to do it. Instead, you specify the outcomes, and then you allow the people to experiment with ideas to achieve those outcomes in the same way as we do with product development, and then every day everyone's asking themselves, what's the challenge we're trying to achieve right now? What's the actual condition? What obstacles are in our way? What are we going to try next? When can we go and see what we learned from taking that step? So I guess my conclusion for this is we want to take an experimental approach, not just to product development, but also to process improvement. The processes that you have are the wrong processes, and you'll know I have the right ones, but the important thing is to constantly think about improving your processes with the particular goal in mind, and we should all be doing that. If you leave your development process is the same, they don't stay the same. What happens is they gradually degrade over time and become worse and worse. If you're not constantly working to improve, then by default you're gradually getting worse. And so I want to end by just what I started with. Don't automate for the case where you're right. Assume that what you're doing is not the best thing you could be doing. Focus not on cost, not on estimation, but on how we can best provide value in our products and in the processes that we're running. Build feedback loops and grow and water and tend to your feedback loops too. Validate your assumptions and expose your assumptions. Work to make it so that you can get feedback in small batches, both for your product development and for your process improvement work, so that you can take an experimental approach, not just to product development, but also to process improvement. Thank you for listening, and we'll see you next time.